And the fun keeps coming with another AIME problem. 2016 AIME 2, question 4. An A by B by C rectangular box is built from A times B times C unit cubes. Each unit cube is colored red, green, or yellow. Each of the A layers of size 1 by B by C parallel to the BC face of the box contains exactly 9 red cubes, 12 green cubes, and some yellow cubes. Each of the B layers of size A by 1 by C parallel to the AC faces of the box contains exactly 20 green cubes, 25 yellow cubes, and some red cubes. Find the smallest possible volume of the box. So what I did for this, I just drew that rectangular prism. And the relative lengths of my line segments don't mean anything at this point. I just drew one and labeled one side as A, another side as B, another side as C. And then I considered the 1 by B by C faces parallel to this. So that's going to be sort of cutting off something like this. And in each one of those faces, we are going to have 9 red, 12 green, and some number of yellow. And then I considered the A by 1 by C, which is going to have some number of red, so I don't know how many red, but 20 green, and 25 yellow. And then I looked at this and said, okay, so I'm going to have to, at least for green, because the green is the one that I have both numbers for, I need to end up with the same number of green cubes when I add up sort of stacks of these things going this way, and when I add up stacks going this way, I better end up with the same thing. So that means 12A has to equal 20B, which tells me that A over B is going to be 20 over 12, which is the same thing as 5/3. So that means that A, I can have something like 5x, B, I can have something like 3x. It could be 5 and 3, it could be 10 and 6, it could be 15 and 9. I don't know just yet. And then I thought, okay, well, if this is the case, I need to sort of have some type of similarity here. And so, if I have this similarity, the number of green to the number of green has to match the number of yellow to the number of yellow, to the number of red to the number of red. And so, I know that 20 over 12 for the green must equal 25 over, I'll say, y for yellow. Cross multiply and solve, and I should get 15 for the number of yellows in one of these. And for the reds, I can do the same thing. So 20 over 12 should equal unknown, I'll say r, over 9, and cross multiply here, and I should get 15 reds here. And so now I see that based on this, the number of cubes in one of these faces, in this B times C face, has to equal 9 plus 12 plus 15, which is 36. And I see the number of cubes in one of these A by C faces. So A times C has to equal 15 plus 20 plus 25, which is 60. And I actually just guessed a couple of things and got the answer, but you can do it directly by changing out the A for 5x and the B for 3x, And so you get 3x times c, 5x times c, that's going to equal 36, that's going to equal 60. Dividing, you still get 12. And the thing that you have to consider here is what's going to give me the smallest volume. So I see that if x is 1, that implies that c will be 12. But if x is 2, that would imply that c would be 6. And we should know that for the areas of the faces, so this area is constant. I want to get the smallest volume, I want it to be far from a square. So we're not going to want to have it be sort of equal on all sides, because then when I multiply, it's going to be too big. So just case in point, the answer is 5 times 3 times 12, which gives me 180. If instead I let x be 2 and got 10 times 6 times 6, these both get multiplied by 2, and this one gets divided by 2 once, so it's going to be actually twice as big, 360. Or if I let x be 3, these both would get multiplied by 3, and this would only get divided by 3 once, so it would be even bigger. So the answer is 180. Questions in the comments if you have them.